Hello, colleagues. I'm very glad to see you here. I'm the last speaker today. I'm going to tell you about Greenplum. How can you use it most efficiently and quickly? These are new comments. I tried to make my presentation as entertaining as possible because it's the last one. I hope that you will like it. And as a review, could you please raise your hands, those who know what Greenplum is? That's really cool. Thank you. And I will tell you what Greenplum is if you don't know what it is. It's a cluster DBMS. It is based on Postgres. It's a sharding Postgres. The basis of it is Postgres 8.3. It's quite an old version, but it also uses new features from new PostgreSQL versions. Greenplum implements column and line store. It's possible to create any table both in columns and in lines, and you can have several partitions in one table. The newest one will be line partition. Greenplum is written on C and Python. This is an open source product. You can download it and use without any limitations. And now Greenplum is the only open source of analytical DBMS. There are no alternative open source elements. And what is it like? Typical architecture is about one big server, a lot of memory, and drives a system. And this system is about a lot of weaker servers. Each of that have their own memory and drive massive. They can be sharing mapping and non-sharing mapping. It means that in the first option, every server has its own set of elements. For example, a typical cluster of Oracle RAG where every server has its own memory. But they have common drive massive. The advantages include linear growth of productivity when new servers are added into the cluster. It's also quite easy to expand resources. And it is fault tolerancy, because clusters will work even if a server fails. But there are disadvantages such as difficult management, difficult administration, and high requirements to hardware, especially to network. And if we use logical scheme of Greenplum, it will look like that. We have one master host with master segment. Segment in Greenplum is instant in PostgreSQL, and there is a secondary master that takes the role of the main one in case the main master fails. Master is the entry point for all customers into the cluster, so all clients communicate with master. There are several or one interconnect networks that are not available to clients, and they are linked to the segment hosts. Here we also have segments that save and process data. Every segment can have a mirror. In particular, here segment 1 has a mirror that is located in the last host in the cluster. If the segment fails, its load will be referred to its mirror that will be switched on instead of it. The mirror shows the latest version of these segments. Replication is simultaneous. So if you received commit from the master, it means that the data were committed to the mirror and to the segment, and the master has collected commits from every segment in the cluster. If any cluster elements fails, cluster will not fail. If master host fails, will not result in the cluster failure as well. If any segment fails, cluster will still operate because segments on other nodes will switch on. Also, here it's possible to use several interconnect networks, so even if one interconnect network fails, the system will still operate. Why was Greenplum made? Well, first of all, it has to solve specific tasks where we have a lot of data and few queries. Normally, this is about analytics for clients, reports, ad hoc queries from analysts. They're quite similar to reports. And marketing campaign. It's quite an often case as well. What does Greenplum not like? Well, it does not like a lot of queries that process small volume of data. That is about OLTP load. Greenplum is used in companies that have a lot of data and that are to analyze these data. Historically, the largest customers, the consumers of Greenplum were telecom companies, insurance companies, and financial companies. And in Russia, this tradition has continued. All these companies use Greenplum. Greenplum looks like Postgres for clients. And that's why software that can be used with Postgres can be used with Greenplum as well. And a very good soft, in particular SAS and Informatica, have additional connectors for Greenplum that make it possible for this software to communicate with Greenplum in parallel, so they communicate with segments directly, and that's why productivity of this software is much higher. And in what cases you shouldn't use Greenplum? As I said, Greenplum is not a substitute for sharding database, so if you have typical Postgres and you insert data line by line and you understand that it is about the volume of the database or the productivity of the database, Greenplum will not save you because it cannot work with a lot of queries per second, and you should not use a lot of direct users whom you cannot control. Because Greenplum, due to its specific features, due to its cluster nature, cannot work well with a lot of sessions that work at the same time. Speaking about hardware, well, Greenplum can work on any x86 servers. It's up to you what server you choose, but you are to consider the ratio of CPU to space. If you think that you won't just store the data, but you will analyze the data, you will process the data, then it's better for you to increase the number of servers or to have a more powerful CPU. And you have to think about it in the very beginning. It's not good to use RAID 5 or RAID 6. It's better to use RAID 10 or RAID 1. Well, yes, it's more expensive, but it's more reliable. And the productivity is higher here because in case one drive fails, speed is decreased, and the probability that the second drive will fail as well is quite high. In the case of RAID 10, productivity does not decrease at all. You shouldn't use it on virtual systems. But if virtual machine is much cheaper than physical servers, you can use them. It should be decided on case-by-case basis. But normally, you should understand that productivity on virtual machines will be about 10% lower. So we decided to use Greenplum. What should you start from? At first, you should think about the number of servers and segments that can be lost in your cluster. Greenplum makes it possible to build flexible configurations. So, if one server fails, its load will be divided between all the servers in the clusters. So, productivity will not be lost here. Another situation is when all the load from the failed node goes to its neighbor. So, on the one hand, the cluster works twice slower because Greenplum works as slow as its slowest segment. But on the other hand, you can also lose a lot of servers in the cluster, apart from the one that has the replicas of the failed server. It is also quite good for you to use this feature of Greenplum. It's possible to create specific table spaces within one DBMS. This is about the space on drives of servers in cluster. So one table can be divided into several partitions, and every partition may be stored on specific devices in the cluster. The newest data, the oldest data, and relevant data. It's quite a flexible system, and you should use it at once. Also in Greenplum, you should pay attention to the key of sharding. Using this key, this can be one or several fields in a table. Greenplum can distribute data in cluster if this key was selected in the appropriate way. If you build a good logical model, then all join operations, and in typical data warehouses, join operations are most important. These operations will be conducted very quickly because they will be conducted locally on segments without distributing data in cluster. So Greenplum will join small elements of data in segments. If the distribution key was not selected in an appropriate way, then Greenplum will have to conduct one of two operations. It either redistributes one table in cluster using new distribution key, or one table, if it is small enough, can be divided for each segment in the cluster. Another story is monitoring. So, my recommendation to you, please monitor everything, store all the metrics, and be able to analyze these metrics. You should pay special attention to drive subsystem, because Greenplum can be quite harmful for drives. And also I would like to point out that it's necessary to collect data for hardware, CPU, memory, smart data. If it is provided by your drive, so your controller, and your data about your data in Greenplum. So, what data you received, how the tables were bloated, and how is it correlated with the load on the servers. It will provide you with a lot of information, and you will have opportunities for optimization. What should you do if you realize that you need more servers? That the space that you have is not sufficient for you? Well, there is such operation as expand. It's quite a simple operation, but you will have downtime about 30 minutes, and in 30 minutes you will get a base where n new servers were added. After that, you launch redistribution of tables in background mode. Greenplum will redistribute data to new servers. You can also manage this process. You can launch it on weekends, on business days, so it's quite flexible. Another good practice that I recommend you to do from the very beginning, when you started using Greenplum, that is collect the sizes of all tables and all objects in DBMS from the file system. It's possible to get the volumes of files and merge them with the names of tables. So for every table you can say, part of this table on this server takes 10 gigabytes, and on this server it takes 100 gigabytes. So it means that something is wrong. The table was not distributed evenly. It's a very good step, and you should do it by all means. And it also will be very good for you to set automatic search of these tables that are not distributed evenly because distribution key was not selected correctly. It's not difficult, and the productivity of the base will be much higher. Well, I have already told you about joins, these two operations, redistribute and broadcast. Greenplum will have to do one of these operations if you do not use distribution key when joining two tables. Greenplum does not have hints, but there are several ways you can make it choose the way that it is to choose to implement your query. You can also choose the type of join and whether you should use the index or not. And it is also a good practice to analyze your process. In that case, you will save a lot of time. Speaking about data storage, there are two types of tables. Heap tables is a typical PostgreSQL table. It can be stored only in lines, no column storage here. It works with OTP load quite well. I mean updates, deletes and inserts of few entries. But if you want to download a lot of data, a lot of lines at once, that will be quite problematic. Append optimized is the main advantage. You can choose the type and level of compression for every column. For example, if you know that there are a lot of repeated values, you can use compression and compress it after that once again. And the second column that does not have a lot of repeated values can also be compressed. And you should use partitioning mechanism and different file spaces. You should store fresh data on fast devices and old data on cheaper devices. Greenplum is about Postgres. It is related to NBCC. The previous speaker told you about it. So anyway, you will have to vacuum your tables. Greenplum has auto vacuum, but I do not recommend you to use it. It is much better to write your process of vacuum that will suit the tasks that you resolve on Greenplum. So it will be better to vacuum the tables after the process is finished during downtime of the cluster. Also in Greenplum, it's necessary to collect statistics for your tables. This statistics is used by the scheduler when choosing the way of query. It requires one operation, and it's better to do it manually, because you have all the views, you can read documentation, and you get better switch off the automatic analyze. And if you use partitions, and I hope that you want to use them now, you will need a process that will transfer data from fresh partitions to older partitions to a cheaper data warehouse. It's also quite easy. Also, you can use disks for the data that were not included into the memory. This is called spilled files. So intermediary data is in the memory. After that, if the memory is not sufficient, this data should be recorded on the drive. Of course, it would take some time. So it's better to set the management of spill files to limit their upper limit. And Greenplum has two ways of restrictions in terms of resources, resource lines, and resource groups. Lines become deprecated, and resource groups is a new way to limit the user in terms of memory, but not in terms of drives. I hope that we'll have it soon. Also, Greenplum has another good feature, that is PXF, Platform Extension Framework. It enables Greenplum to communicate with external data sources. For example, if you have an external database management system, for example, Postgres or Hadoop or any other system, then you can tell the segment of Greenplum to go there and take part of the table from this source. So the downloading process will be quite quick with the use of all networks in Greenplum cluster. And now, 4 external sources have been implemented, but it's also quite easy to write your own source. You should know Java for this purpose. And what do we do, for example? We use PXF in our platform. Our platform has 3 parts: Hadoop cluster, ADB cluster, and in-memory computing grid cluster that can deal with OTP load quite well. We use NiFi to create external tables in Greenplum that check the data sources. And we use Zeppelin to provide access to Greenplum. What is the advantage here? In Greenplum we have one table, and this table has several partitions. Each partition can be connected to the external system. For example, historical data is in Hadoop, actual data in Grid, the new data are stored in Grid as well. And there is another partition that can be stored in Postgres, for example. And here we use doubling to get this data. And for the user that addresses Greenplum, it looks like one table. The user does not know what is there inside. The user writes a query to one table. And if the user does not touch the data that is located in Greenplum, then Greenplum will not actually address its drives. Now, I would like to promote our distributive just a little bit. We use the latest version of Greenplum that has been tested by us. We created our own monitoring, our dashboard for administrator. We used open source components here. So if you use your own monitoring system, you can switch off part of our system. You can use Zabbix, for example, and set Zabbix as a source for our system. It's quite simple. We commit a lot of changes into the Greenplum core. In particular, recently we prepared a new type of compression because tests have shown that this standard is used for all compressions. And also, we provide consulting and support services. And we support the users of Greenplum. Our distributive consists of Greenplum core and additional features. Sprint 1 and Sprint 2 have been closed. We started working with Greenplum in September, and now we work on the third sprint on integration with other systems and on various management systems and their simplification. Here is our monitoring. We use standard stack that is Graphite, Grafana, and Zeppelin. It works out of the box. It can be set. Administrators do not have to do anything, but if you want to change it, you can do it. And also we can use Greenplum in clouds, on virtual machines. Quite often it is profitable for dev and test environments, although it's not as efficient. Still, it can be a bit cheaper. I guess that's it. Just, I would like to tell you that we're looking for administrators in PostgreSQL that will work with clusters, megabytes, and data. So, if you're interested in it, you can come to our booth. Thank you for your attention. Do you have any questions? Regarding NiFi, well, NiFi is an open source retail. Do you need more detailed information? Well, we are based on open source, but we have our own features. For example, our monitoring modules, the modules for collecting the volumes from the tables. This is not open source. That is something created by us. But the additionals that we implement in the core are open source. You mentioned data petabyte, and well, you mentioned a petabytes of data. And how much data can your system manage now? We are a vendor and we do not have clusters themselves. We build them with our clients. Regarding the volumes in our clients, well, in Russia there are clusters with about 100 terabytes of compacted data. And there are even larger clusters in the world, but I would say that there are several hundreds of terabytes. You showed a slide where there are queries to external sources. And what about the transfer here? You mean the transfer of data from external system to Greenplum? Both the Greenplum, well, I understand that a client gets the data from Greenplum master. And what about the delay? Have you checked it? No, we do not have any data, but Greenplum is an OLAP system, and normally it is used for corporate data warehouses, and there is no goal here to decrease the delay. The main goal there is to increase the productivity of data processing, so delay is not really important here. It's important that the data is processed quickly. Throughput is important. It was a good question. I think that we need to measure the data delay. So how quick the customer will get that data is quite a good case. We need to measure it. Thank you. And do you have any more questions? Thank you.